Hey, this is Brian Stillman from BeTerrific. We're at CES 2020 on the final day of CES. It is a Friday, and it's still going strong. You can see all around us, there are people everywhere. We are in the South Hall, and there's lots of 3D printing all around us, but we are specifically at Markforged. You guys do 3D printing. You have 3D printing devices, 3D printers that are designed for industrial use,
Yes.
designed for manufacturing.
Yep.
So what does that mean? This isn't your typical plastic, spools of plastic 3D printing. This is a little bit more advanced.
Yeah, so we do composite and metal 3D printing. So we do a base material that's chopped carbon fiber and nylon. So that is our basis. So it's a plastic material. However, we were actually the first company to print with continuous strands of carbon fiber. And so we were the first. That's what we started out with to go into the industrial space. Was to bring more functional prototyping and use parts, tooling, and fixturing, so we can reinforce those plastic parts with fiberglass, Kevlar, high strength, high temp fiberglass, and carbon fiber as well.
Wow.
We also then, since the start of 2018, I've been shipping our Metal X 3D printer. So we can currently print in 17.4 stainless steel, A2, D2, and H13 tool steel, and Inconel 65. We also have 316L stainless steel and titanium that are still in beta, and we actually will be releasing copper pretty soon.
It's pretty amazing. I know one of the things that you do is to keep the parts lighter, there's this sort of triangular cell structure in the 3D printing, so it keeps the parts light but strong. I mean, this looks like a chunk of metal, but it's not. It's 3D printed.
Yep.
So it's light, it's strong, it's does everything it needs to do, whatever this widget is.
Yeah.
But you're talking about the carbon fiber strands. This is an example of a plastic, just plain plastic, and one
versus
with
carbon fiber. Yeah.
So what's the difference between these two? Because they look the same from the outside.
So we cut out. It's hard to see, of course, up close right now. But on the inside, you can see there's a different. Here, it's cut out, so it's just our chopped carbon fiber. Here there is a layer inside, so we layer down continuous strands of carbon fiber onto the inside, and we have our own slicing software. You have to do a regular STL file, and we will help you optimize where to put those reinforcement fibers and what direction you want, and where the placement might be in order to really add the strength to it. Usually you don't go ahead and reinforce the entire part. It's not usually worth it at that point.
Right.
If you can selectively do it, though, to really add strength or different properties, depending on what material you're looking for, into your part.
So it adds strength. Just by way of example, so again, two pieces of plastic of 3D printed material. One is plastic, one is reinforced plastic. So I can bend the plastic one, no problem. Bends, great, just like you'd expect. This is the reinforced one, and I'm not faking this, but I cannot bend this at all. I can't break it. Yeah, it's not flexing at all. I'm honestly trying. I am not super weak. It does not bend. So that's the properties of the reinforcement, right?
Yeah, it adds that extra stuff. So a lot of 3D printers are being used for proof of concept prototyping, but that part usually can't be used for actual testing on.
Okay.
With functional prototyping, you're actually able to test on that part. You might end up still choosing to go and machine it afterwards, but you can produce parts that will mimic the strength of whatever you are producing afterwards. We are also still used for end-use parts, so people have used carbon fiber or Kevlar reinforced parts to replace aluminum parts, for example, or adding lighter weight parts to things that maybe don't actually need some properties that metal might have, but they just need the strength behind it. So that's something that kind of you get from the reinforcements.
Is that one of the printers?
So this is our sintering oven, actually. That's So the metal printer is actually behind it.
Oh, okay.
So our metal process is our printer, our wash, and our sinter. So our printer is metal powder bound in plastic. So it actually safe to print in the office space. So you don't have to worry about breathing in any toxic fumes from that.
Oh, okay.
So it puts it down layer by layer, FDM style printing.
Right.
And then that part goes into our wash, which goes and removes the binder from that, which finally goes to our sintering process, which pulls it finally into a full state metal part.
Wow, very cool. Great. Now, if manufacturers are interested in taking advantage of this, getting one of these units, how does that work? Do they reach out to you? And
yeah, they can reach out to us. We have our contact information on our website as well.
What's the website?
Markforged.com.
Markforged.com.
Markforged, or you can just email us also at sales@markforged.com. But we work mainly through our resellers. So some of our lowest end composite printers you can purchase directly on our website, but otherwise you will either put in touch with one of our resellers as well that's more local towards your area to get you your printers.
Great. So Markforged, 3D printing, but on an extremely high end, super strong, designed for industry. Just one of the many things you'll find at CES. Stick around. This is Brian Stillman with BeTerrific. We'll be bringing you the final hours of CES 2020. We'll have more for you soon. Stick around.